Hi everyone, welcome to this brief introduction to our 2017 KDD paper. In this paper, we study the problem of POI recommendation, which is usually done based on the check-in data. The check-in data is usually very sparse. We have only a few ones among the many question marks. On the other hand, we have rich context around both users and POIs. For example, users interact a lot with each other, and on the POI side, we have rich categorical, geographical, temporal, and sequential information, and etc. However, there is a lack of a uniform system that conceptually can take any rich context into consideration and keeps to deliver meaningful recommendations even any of the context is missing. To address the problem, we find semi-supervised learning a natural and principled solution for POI recommendation. The idea for semi-supervised learning is to leverage unlabeled data to improve the overall performance. In our scenario, the various contexts can be naturally built into heterogeneous context graphs. The data scarcity can be alleviated by enforcing smoothness based on the context graphs. Specifically, we develop a neural approach to bridge collaborative filtering and semi-supervised learning. In the first layer, we use a fully connected neural network to compute the latent factors for users and POIs. On top of it, we add two unsupervised laws based on the context graphs. For example, this is a context graph of users. By sampling random paths on this graph, we can preserve the similarities among users by predicting the context on this graph. Similarly, we can build the heterogeneous context graphs for POIs like this. This graph includes categorical, geographical, temporal, and sequential information. Finally, we add a supervised loss on top of the user and POI embeddings. This layer includes multiple hidden layers of feed-forward neural networks, and it is used to fully explore the interactions among users and POIs. We designed and implemented a joint training framework on TensorFlow, which runs quite efficiently on CPUs and scales well on GPUs. For more details, please refer to our paper. Thanks.